Okay, so I realized somebody that get logged in at the end didn't have time or a lot of time to work on these, but let's go over them anyway and see just if you got started in the right direction at least. So for the first one, remember our first top level of priority for our order of operations is those enclosing symbols. Here we have a parenthesis, so we're going to work inside there first. No more enclosing symbols inside there, so our next step is to look for exponents. We have no powers or roots. Next is multiplication and division, and we will do those going left to right. So we have the 4 times 6 first, which is 24. And again, reiterating from Wednesday, everything else in the problem stays exactly the same. We just replace the 4 times 6 with 24. Now, I'm going to do a little thing to cheat here to speed up the process. Rather than rewriting the problem at each step, I'm just going to replace the numbers. 24 divided by 2 is 12. I'm just going to take those out and replace it with 12. Now, inside those parentheses, there's nothing left but subtraction, so we're going to work left to right with the subtraction. 19 minus 12 will give us 7. And then finally, 7 minus 5 gives us 2. And we have that parentheses down to a single number, so I'm going to get rid of the parentheses, remembering that that parentheses can serve other purposes, and here that's multiplication. So we have to put in that multiplication when we remove the parentheses. Now we do have multiplication again, 2 times 2, which is 4. And now it's addition and subtraction working left to right. 7 minus 4 is 3, and 3 plus 3 is 6. So 6 is our result. Over on the other side here, number 2. Remember that fraction bar means we have to do the top and the bottom separately, then divide them once we have them completed. So on top, no other enclosing symbols, so we'll do the exponent. 3 squared is 9. Then we will multiply. 6 times 5 is 30, and 2 times 9 is 18. 30 plus 18 gives us 48 on top. On bottom, again, no other enclosing symbols. We do have an exponent. 2 squared is 4. 7 times 8 is 56. Minus 11 times 4 is 44. We subtract that to get 12. Now that we've done the top and bottom, we can go ahead and divide. 48 divided by 12 is 4. So we get a result of 4 for that second problem. Anybody have any questions on order of operations? I know that seems like one of the more basic concepts, but I always have a few students who get one of the order of operations questions wrong on this first exam. So make sure you're going through those carefully. So today, our new topic today is part of one of the biggest concepts in math, probably the most useful, most applicable concept in math. That is ratio and proportion. Now we're going to do ratio and proportion in more detail in Unit 2 of this course. But for right now, I want to talk about one of the most common applications of ratio and proportion. That is percent. Understand the concept of percent. We first need to understand the word itself. Percent is actually 2 words put together. Per, if you think of miles per hour, dollars per hour, miles per gallon, that means out of or for each. And cent, if you think of cents in a dollar, years in a century, 100. So percent means out of 100. So if I have 38%, that literally means 38 out of 100. It's a ratio. In fact, it is that simple to convert a percent into a fraction. If we put that ratio in fractional form like that, it's already there. We've done the most of the work. Now we would want to reduce that. We wouldn't want to leave it as 38 over 100. Both 38 and 100 could divide by 2. So 38 divided by 2 is 19. 100 divided by 2 is 50. That's 19/50ths would be that result if we reduced it. Now, a lot of people mistakenly call this a fraction. And it looks like a fraction, but what it really is it's turning it into a ratio. It is in a fraction form, but it's not really a fraction. So if I give you something like 265%, when it says convert it to a fraction, it's really saying convert it to fractional form. It's a ratio. It's really a ratio. But when we go ahead to do that, since the percent means out of 100, again, it's just going to be 265 out of 100. Now we'd want to reduce this. Now something that we do a little bit different here. Is my screen share not working? Looks like it's not coming up. Give me just a second. I'm going to stop sharing and reshare, see if it comes back up. Okay. Give me a wave. Are you guys able to see my computer screen on your end, or is it not coming up? Just raise your hand if you can see my computer screen. You guys can see it okay? Okay, for some reason it's not showing up on my control panel, but we'll keep going. If it disappears or anything, just unmute and give me a yell if anything goes wrong. So my control panel for some reason is not showing it today. Okay, so anyway, we'll keep going with this. So 265 over 100. One of the things that we would do here that we normally would not do with a ratio is we will split it into a mixed number. 100 goes into 265 twice with 65 left over. So it's 2 65/100ths. And then we do still have to reduce the fractional portion of that. 65 and 100 both divide by 5. Give me 65 divided by 5 is 13, and 100 divided by 5 is 20. And don't forget that too. We might have 56.25%. So if I go to change this into a fraction, once again, it is just 56.25 over 100. Now, again, we need to reduce this, but when we see decimals within our fractions, we don't like to keep them that way. We like to get rid of them. And just like with dividing decimals, one of the ways we get rid of them is multiply by 10 or 100 or 1,000, whatever it takes to move that decimal point out of the way. Well, here there's 2 decimal places, so if we multiply by 100, it will get rid of it. So 56.25 times 100 is 5,625. 100 times 100 is 10,000. And now we can reduce. I'm sure you see that both of those can divide by 5, but they can also divide by 25. So let's do that to get a little bit larger here. 5,625 divided by 25 is 225. 10,000 divided by 25 is 400. Looking at those, we can still reduce each of those by 25. 225 divided by 25 is 9. And 400 divided by 25 is 16. So 56.25% is the same as the ratio 9 to 16, or 9 out of 16. we might have 18 and 1/3%. Again, if we're turning this into a ratio or fraction form, we will make it 18 and 1/3 out of 100. Well, just like up here where we didn't like having decimals within our fractions, down here we don't like having fractions within our fractions either. So, to get rid of that fraction, we have two choices. One, we can do like a least common denominator method. The only denominator within the ratio here is the 3. So if I multiplied both the top and bottom by 3, 18 and 1/3 times 3 would turn out to be 55. And 100 times 3 is 300. And then I could reduce that. What's probably a little bit simpler, at least to me is a little bit simpler, is to take that fraction. And remember, we said fractions and division can kind of be very closely swapped with each other. Turn that into 18 and 1/3 divided by 100. Now again, I have to make that 100 into a fraction to divide with fractions, so I'm going to do that 100 over 1. 18 and 1/3, I got to make it improper, will be 55 over 3. Times the reciprocal of 100 over 1 will be 1 over 100. Now I can either multiply and reduce, or I can cross cancel. I'm going to cross cancel here to speed things up. 55 divided by 5 is 11, and 100 divided by 5 is 20. So 11 times 1 is 11, and 3 times 20 is 60. Are we having technical difficulties on your end at all? Okay, so our next step. Let's take a look at converting percents to decimals. Well, we know if we have 42%, that just means 42 out of 100. And we saw in the last class that converting a decimal to a fraction is simply taking the numerator divided by the denominator. 42 divided by 100. Or a fraction to a decimal, I should say, which is 0.42. Now this, again, they mistakenly refer to it as a decimal. It's really decimal form. The proper name for it is a rate. So a rate is just a percent that has been put into decimal form. So the difference is 42%, as we said, is 42 out of 100. That is the percent form. A rate, remember we said rates are always usually converted to unit rates. It's out of 1. So we have to reduce that down, dividing by the 100 here. 100 divided by 100 gives us the 1. 42 divided by 100 gives us 0.42. So that rate is really 0.42 out of 1, or we simply write it as 0.42. Going the other direction, if I have a rate and I want to turn it back into a percent, it's simply remembering that that rate, 0.23, is 0.23 out of 1. We want to turn it into a percent, which is always out of 100. Oh, that's multiplying by 100 to turn the 1 into 100. So you multiply by 100 to turn 0.23 into 23. 23 out of 100, or 23%. Going to a fraction. Well, once again, 5 out of 8 would be our, technically it's our ratio in fraction form. To turn it into a percent, percent is out of 100. Find that missing number. We could try to figure out what do we multiply 8 by to make it 100. but it's not going to be a nice even number. It's actually going to be a decimal here. So there's a shortcut. What we can do to figure out what that is that we multiply the 8 by is we can work backwards. 100 divided by 8 would give us that number. So then we can just go up here and multiply the 5 by that number. Notice what we get is 5 times 100 divided by 8, which in this case will be 62.5. But more importantly, if I look at the geometry of this problem, 5 times 100, those are the two numbers that are diagonal with each other, divided by 8. 8 is the number that is diagonal with our missing number. So the process is called cross multiply and divide. It's just a shortcut of this to basically work with our equivalent fractions. I'm having some more glitches here on my end. I'm going to shut the system off quick and reboot. I'm going to be right back in about 1 minute. Okay, let's see if this works any better here once I get my screen share back going. Looks like my recording is still going. Yep, okay. There, the system's looking a little bit better on my end. Hopefully nothing was coming through too poorly on your end. Okay, so we can convert our percents to ratios and rates and to those different forms. The more important thing is to be able to calculate with these. And there are two main methods that are used to try to calculate percents. One is what we just saw when we were converting our fractions or our ratios. If we have a ratio of 3/4 and I'm converting it to a percent, we set up that proportion, and we solve it by cross multiplying and dividing. So the first method we use for percents is called the proportion method. Now you'll notice I'm leaving the other half of my screen here blank. I'm going to come back and do each of these problems again with the other method that I want to show you. So as you're following along in your notes, make sure you leave a blank space on the other side or after each problem so you can come back and do it again in another method. So a simple question we might get asked might be, find 35% of 80. So here we're going to start out with the percent, 35%. And that is just 35 out of 100. Now, before we go any further, let's talk about the 35 and the 100 and what they mean here. The 100, first of all, is the whole thing, or what we refer to as the base amount. Excuse me. Pardon me. The base amount is the whole amount, or it is the amount that all of the other calculations in the problem are based off of. It is the starting amount. Or like we said, the base value. The 35 then here is referred to as the portion of interest. It is a portion of that base amount. Now, the word portion can be a little deceiving because it's possible for that to be larger than the base amount. But it is that piece of the base amount that we're focusing in on. Now, on the other side of our proportion here, we have to match numbers up with the 35 and 100. The wording of 80 can be read out of 80, which signals us that that 80 goes on bottom. That 80 is our base amount. That is the amount that all of our other values in the problem are based off of. To find that missing value, then, we're simply going to cross multiply and divide. So 35 times 80 is 2,800. And then divided by the 100 gives us 28. So 28 is 35% of 80. Next, let's take a look at blank is 160% of 40. So again, we start out with the percent. 160% is 160 over 100. Now you'll see here that portion of interest is bigger than the base amount. 160 is bigger than 100. So on the other side over here, we're going to expect to see the same thing. That top number is going to be larger than our bottom number. Once again, here we see of 40, and we can read that as out of 40. It implies the 40 goes on bottom. And in the solve, we'll cross multiply and divide. 160 times 40, 6,400. Divided by 100 is 64. So 64 is 160% of 40. Again, since it's more than 100%, it's larger than that beginning number, larger than that base amount. Here we have 42 is 70% of blank, of some missing number. Once again, we start with a percent, 70%, 70 over 100. Next, on the other side here, oops. Right. 42 is 70% of blank. Of blank, again, can be read as out of blank, which implies that that missing number goes on bottom here. 42 is 70%, implies the 42 matches up with the 70. Now you'll note we're missing a different number here. On this last example, we're missing the top number. Here we're missing the bottom number. But the calculation is just the same. The pattern's a little different, but it's the same. We find the two numbers that are diagonal, the 100 and the 42. We multiply those to get 4,200. Then there's a number that's diagonal with our missing number. That's the one we divide by. We divide by 70. So 4,200 divided by 70 is 60. Or we might have 27 is 90% of blank. Again, we start with the percent. 90% is 90 out of 100. Now, again, I've talked a lot about estimating this semester. We see that the 90 and the 100 are really close to the same value. So I'm expecting these two numbers over here to be close to the same value. Of blank, again, I can read that as out of blank. Once again, it implies our missing number is on bottom. Next, 27 is 90% and 27 top. And to solve, we cross multiply and divide. 100 times 27 is 2,700. Divide by 90 gives us 30. So 27 is 90% of 30. And we'll note this does make sense. The 27 and 30 are very close to the same value, just like the 90 and 100 were close to the same value. So next, let's take a look at 48 is blank percent 60. Now, here we're missing the percent. In all of our other examples, we have started with the percent. We're going to do the same here. Even though the percent is missing, we're going to leave it as a blank out of 100. We know that whatever that percent is, it's going to be out of 100. Equals, now the other numbers will go on the other side. Once again, of 60, we read out of 60. 60 goes on bottom. 48 is blank percent, implies the 48 goes with that missing percent. So now we cross multiply and divide again. Once again, notice the missing numbers in a different spot. Up here it was on bottom, here it's on the left side. But it's still cross multiply and divide. We find the two numbers that are diagonal with each other. 148, we multiply those to get 4,800. Then the number that's diagonal with our missing number, we divide by. So we divide by 60, gives us 80. 80 out of 100, or 80%. 48 is 80% of 60. Now, as I mentioned, that is one of the methods that we can use to solve our percent problems. The second method we could use is called the rate method. And I'm going to solve each of these problems using the rate method. I prefer the proportion method just because the proportion method saves a lot of mistakes. You just got to match things up, and you don't have to, it's always, calculation is always cross multiply and divide. The rate method can be quicker and shorter, but it's a little bit more complex to get correct. So looking at this problem, find 35% of 80. Well, the first step in our rate method is to find the rate. In other words, to convert the percent into a rate. So here, 35%, remember converting it to a rate is just that decimal form. That'll be 0.35. Next, we need to know what we have. Here we have that base amount. When we have the base amount, in the rate method, we take the base amount times that rate. So here that's going to be 80% times our rate of 0.35. Gives us 28, exactly what we had over here. Maybe even a little bit quicker, a little bit simpler. Let's go down here. So for this one, our percent is 160%. As a rate, that is 1.6. Next, we take our base, which is 40, times the rate of 1.6, which does give us 64. Same result we had over here, again, a little bit quicker. So for those types of problems where we have the percent and the base amount, this rate method is very, very quick and very simple to do. But not all of our problems are of that form. We look at this next one here. We do have the percent, 70%. Converting that to a rate is 0.7. But here we do not have the base amount. Here we have the portion of interest. And when we have the portion of interest, we take that portion and we divide it by the rate. So here it would be 42 divided by 0.7 to get 60, which is the correct answer. And again, that was quicker than setting up the proportion and cross multiplying. The problem is we had to determine, once we get the rate, are we multiplying by it or are we dividing by it? Then a lot of mistakes get made there. For the next problem, same thing, 90% is our percent. We convert it to a rate of 0.9. And once again, we have the portion of interest, so we take that portion of 27 and divide by the rate of 0.9, giving us 30. Well, then this next example, this last example, is a different type yet. We don't have the percent at all. If we don't have the percent, what we do in these problems is we will take the portion of interest divided by that base amount, and that'll give us the rate. So here we have 48 as our portion over that base amount. It was 60, not 60. We divide that, we get 0.8, which is a rate. And of course, that still has to be converted into a percent of 80%. So that rate method is quicker. It's just a matter of making sure you know what pieces you have and choosing the correct approach. Whereas the proportion method is always, once we set up the numbers, get them put in there, is always going to be cross, multiply, and divide. So the rate method is very useful when we know the base amount and the percent, and we want to find the proportion, or the portion. And there are enough applications out there where that's the case that the rate method does get used quite a bit. I mean, simple interest, commission, all sorts of applications like that where that is the case. So the rate method is very useful. It's just, it causes more mistakes if you have a more complex problem. The other reason I like the proportion method is when we get into our word problems, the proportion method actually just helps us to match things up. For example, FMA Corporation estimates weekly profits as 8% of gross weekly sales. Find the gross sales for a week where profits are estimated as let's see what I want to put in here. $298,720. So when we look at this, just like with our simpler problems, first thing I tend to pick out is the percent, the 8%. And of course, 8% means 8 out of 100. But in a word problem, I try to look at what do they represent within the word problem here. Remember, there's always, when we're dealing with percents, there's going to be one number that's the base amount and another number that's a piece of that, a portion of that. Here, the profits are a piece of the gross sales. So the 8% here represents profit. The 100% is the larger piece, or that base amount, which is the gross sale. Gross weekly sales, if you want to be specific. So now when we set up the rest of this proportion, on the other side, whatever we put on the other side has to represent those same values. So we go to figure out where to put the $298,720. A lot of us would just want to put it on bottom because it's a big number. But we ask, what does it represent? It is the estimate of profits. It goes with the profits on top, $298,700. And now we solve this by cross multiplying and dividing. So we will do 100 times $298,720 divided by 8, giving us $3,734,000. Not a bad week. Anyway, the point is, using the proportion method helps us to set these problems up and make sure that things are matched up by making sure that whatever goes here represents the same thing as the top number in the other proportion. In this case, it was profits. Same down here. Whatever we end up with here has to represent the same thing as the 100. In this case, gross weekly sales. Our percents do not stay that easy. Now, we only have about 8 minutes left. We're just going to touch on this. We will cover percents more in Unit 2 when we look at ratio and proportion. And we'll talk about what we're about to do now, a little more detail at that time as well. But let's say that we have Sam purchases supplies listed for $860. Now first, let's talk about that word listed. Listed means that is the price they are posted as. Like if you walk into the store, the list price would be the price on the shelf for that item. There is a 7% shipping charge. Find the total that Sam pays. Okay, so once again here, we have a percent. 7%. 7% is 7 over 100. As we look at what those represent, the 100 again has to represent the amount that everything's based off of. Here, that would be that list price. The 7% is a piece of that, and that is the shipping charge. I'm just going to write shipping there. So on the other side of this, we have to match up. The $860 is the list price, so that is going to go on bottom. And we will cross multiply and divide. 7 times 860 divided by 100. Gives us, $60.20 is what that should come out to be. That is, now we have, like any of our word problems, we have to go back once we've done a calculation and make sure we have answered the question. The question is looking for, find the total that Sam pays. Well, the $60.20 is the shipping, not the total. So here we would have to do the next step. We take the $860 list price and add that shipping of $60.20 to it, giving us a total $920.20. That is what Sam pays. So we had to take that extra step of adding it together at the end. But if we look closely, we see that there's an alternative. Rather than having to add that back together, if we look at this, the 860 is 100%. That is the base amount, the list price. The $60.20, that represents the 7%, the shipping cost. Then if we add the prices together, we should be able to add the percents together. 100 plus 7 is 107%. The $920.20 should represent 107%. And if we look at it, 107%, 107 out of 100, and we still put the list price of $860 on bottom. If we cross multiply and divide, we do get $920.20. That final price is 107% of the list price. This is what we call a percent increase problem. And when we do these problems, we could very well just find the amount of the increase and add it on like we did over here. in most cases. Sometimes, though, if we're working backwards, if we know the final amount, trying to work backwards, that won't work. Similar to that would be Pat purchases items. Listed at $1,280. Pat receives a 12% discount. Especially in medical supplies, if you are a supplier yourself, a retailer, you'll get a discount if you purchase from another company. It's called a trade discount. 12% is pretty typical. So they're going to pay less than what a customer off the street would pay for that merchandise. So we're going to find the amount paid. So once again, we'll start with that percent. We have the 12%, 12 out of 100. And we'll break down what each of them represents. Well, the 100 still represents the list price. The 12% in this case is the discount. So when we go to set this up, the list price, the 1,280, goes on bottom with the other list price, the 100%. And we cross multiply and divide. 12 times 1280 divided by 100 is $153.60. Now again, we look at the problem to figure out, did we answer the question? The question was asking us to find the amount paid. This is the discount, not the amount paid. So we would have to take that extra step. $1,280 minus $153.60. We do that subtraction, we get, add the zeros, borrow, I guess I didn't need to borrow that. So 0, 4, 6, 2, 1, 1. $1,126.40 is the amount paid. That's what we're looking for. Now, similar to the last question, we could have adjusted our percents. If we look at the $1,280, that represents the list price, or 100%. The $153.60 is the discount, or the 12%. Just like when we did an increase, we added the percents. When we do a decrease, we can subtract them. That $1,126.40 is just 80%, or 88%, I should say, of what we started with. If I found 88% of 1,280, cross, multiply, and divide, it will be $1,126.40. Now again, in this case, it would have been just as simple to find that amount and subtract it as it is to adjust the percent and do that. But when we get into problems where we have to work backwards, we'll need to be able to find that 88% and use it. Or in the increase case, find the 107% and use that. We are running out of time here, so your homework, out of the book, page 36 through 37, is 1 through 51, the odds. Again, doing some of the conversions between percents and decimal form or fraction form. Make sure you do some of the more difficult ones of those, because that's what we'll focus on the test. On Wednesday, we'll do that, and then some of the basic percent calculations. Make sure you jump up and do word problems. Reminder again, the test is next Wednesday. I'm going to send that out right after class here today. I didn't get it done Wednesday, so it should be there with your contact person by the end of the day. You guys have a great weekend. We'll see you all on Monday.